Hello everybody, welcome into another lesson. So today we are going to talk about properties of exponents with variable expressions in radical form. So here we have a simple one of the fifth root of 32x to the fifth. Well, good news is 32 is a perfect fifth. The fifth root of 32 is going to be what? 2. And then x to the fifth is a perfect fifth. It's just x if you take the fifth root of that. So this would simplify down into 2x. And I should specify that we're going to assume all variables are positive for simplicity's sake. All right, that one was easy enough. Now, what if I threw something like this at you? The fourth root of x to the 12th over y to the fourth. Well, whenever you have roots again and you have a fraction inside the root, you can split them up into separate roots. This would be the same as the fourth root of x to the 12th divided by the fourth root of y to the fourth. Well, what's the fourth root of x to the 12th? That would be x to the third, right? Fourth root of y to the fourth is just y. So this would simplify down into x to the third over y. Also easy enough in the end. All right, now let's say we have the fourth root of x to the third times the fourth root of x to the fifth. That's all raised to the negative second power. So we have the quantity of the fourth root of x to the third times the fourth root of x to the fifth, all that raised to the negative second power. Well, again, order of operations dictates we deal with what's inside the parentheses first. Good news is both x to the third and x to the fifth are on the same root. That means we can multiply the bases. So 3 plus 5 is 8. You end up with the fourth root of x to the eighth. All that raised to the negative second power. Now, what's the fourth root of x to the eighth? That would simply be x squared. So you'd end up getting x squared to the negative second power. Now you just multiply the 2 and negative 2, you would get x to the negative fourth, which we know if you have a negative power, it turns into a positive power in the denominator. This would simplify into 1 over x to the fourth. So 1 over x to the fourth would end up being your answer. Alright, so we have 2 times the square root of x times the square root of x to the third, all that, all over the square root of 9 x to the 10th. So we have 2 times the square root of x times the square root of x to the third all over the square root of 9x to the 10th. Well, all these have the same root, so you can just multiply the bases. So 1 plus 3 is 4. This would turn into 2 times the square root of x to the fourth, all over still the square root of 9x to the 10th. All right, now let's simplify these. So square root of x to the fourth is what? That's x squared. So in the numerator, you'll have 2x squared all over your denominator. What's the square root of 9? Well, that's 3. Square root of x to the 10th is x to the fifth. So now you have 2x squared over 3x to the fifth. Well, definitely the power in the denominator is greater than that of the numerator, so the x will favor the denominator. So 5 minus 2 is 3. So this would simplify down into 2 all over 3x to the third. And that would be the best we could do to simplify this. You'll end up with 2 divided by 3x to the third. Alright, let's see. We have the third root of y to the sixth, all that, divided by the third root of 27y times the third root of y to the 11th. So we have the third root of y to the sixth, all that, divided by the third root of 27y times the third root of y to the 11th. Well, let's just simplify the denominator first. We'll keep that third root of y to the sixth in the numerator. Now, the good news is all the roots are the same, so that means you can multiply the bases. So 27y times y to the 11th, that should end up simplifying into the third root of 27y to the 12th. Alright, now let's take the roots of the numerator and denominator. Third root of y to the sixth, that would be y to the second. Now what's the third root of 27? That'd be 3. Third root of y to the 12th would be y to the fourth. So now you're left with y to the second all over 3y to the fourth. Well, 4 is greater than 2, so the variable is going to favor the denominator. So this would end up turning into 1 over 3y to the second. And that's the best we could do to simplify. You'll end up getting 1 divided by 3y to the second. Alright, a little bit different here. So we have the square root of 36x to the third. Square root of 36x to the third. Okay, well, here's the thing. X to the third's not a perfect square, but we can split it up into a factor where one of them is. Isn't this the same as the square root of 36 times x squared times x? Because x squared times x would give you x to the third, right? Okay, so what's the square root of 36? Well, that's going to be 6. What's the square root of x squared? That's x, and then you just have that leftover square root of x that we can't do anything with. So this would just simplify into 6x times the square root of x. That's the best you could hope to do. Alright, let's see. The fourth root of 10 x to the fifth, y to the eighth, z to the 10th. Alright, so we have the fourth root of 10, x to the fifth, y to the eighth, z to the 10th. Well, 10 or any of its factors are a perfect fourth, so unfortunately we're going to be out of luck on that. But let's look at x to the fifth. If we split it into x to the fourth times x, well, x to the fourth's a perfect fourth, so what you can do, you'll have the fourth root of 10 times the fourth root of x to the fourth times x times the fourth root of y to the eighth. Now let's look at z to the 10th. If you took z to the eighth times z to the second, that would also give you that would also give you a perfect fourth. So you'd have z to the 8th times z to the 2nd. Now, whoops, that's a fourth root, not a square root. Now let's take each of these individually. We'll come back to the fourth root of 10. Fourth root of x to the fourth is what? That's just x. So you'll have x. Fourth root of y to the 8th is y squared. Fourth root of z to the 8th is z squared. Now, fourth root of 10 we can't do anything with, so this will all be times the fourth root of 10 times the fourth root times x, so 10x and then z squared. So the best you could do to simplify this is you would end up with x y squared z squared times the fourth root of 10x z squared in the end. That's exactly what you would get. Xy squared z squared times the fourth root of 10x z squared. Sometimes these won't be very pretty, but that's just the nature of the beast. Alright, let's see. The fifth root of 8 x y to the 7th times the fifth root of 6x squared. Okay, my vote is this. I'm going to vote that since these are the same roots, we multiply everything, combine it into one root. So this will end up giving you the fifth root. 8 times 6 is 48. X times x to the 6th would be x to the 7th. Then you just have that y to the 7th. All right, well, let's split these up individually now. This would turn into the fifth root of 48 times, let's look at the fifth root of x to the 7th. If I took x to the 5th times x squared, well, that would just give me the fifth root of x to the 5th. That would give me a perfect fifth. Let's do the same with the y to the 7th. So that'd be the fifth root of y to the 5th times y to the 2nd. That'd also give me another perfect fifth. Well, here's the thing. I don't think we're going to be able to factor 48, unfortunately, because 48 nor any of its factors are perfect fifths. So we're kind of stuck there. But let's look at the fifth root of x to the 5th. What does that give you? That just gives you x. The x squared we can't do anything with, but what about y to the 5th? The fifth root of that is y. So you'll end up with xy times the fifth root of 48. You'll have that extra x squared and then the y squared. So the best this is going to simplify into is xy times the fifth root of 48 x to the 2nd y to the 2nd. That's the best we can do for that. Alright, let's see. We have the square root of xyz times the square root of 2 y to the 3rd z to the 4th. Alright, so we have the square root of xyz times the square root of 2y to the 3rd z to the 4th. Well, same, root, so let's combine everything into one root. This would all turn into the square root of 2x y to the fourth z to the fifth. Let's break each of these up individually now. Square root of 2, there's literally nothing we can do with that. It's stuck the way it is. Same with the square root of x. There will be nothing we can do with that. Now we have a square root of y to the fourth. That'll definitely break down. Now what about the square root of z to the fifth? If we took z to the fourth times z, you would have a perfect square in z to the fourth. Alright, so we'll come back to the square root of 2 and the square root of x, but what about square root of y to the fourth? Well, that's just going to give you y squared. Square root of z to the fourth, that would give you z squared. Everything else, there's nothing we can do with. So you'll get y squared z squared times the square root of 2x, and then that z. So this would literally turn into y squared z squared times the square root of 2xz. That's the best we could do with it. Now this changes a bit. So we have 4 all over the cube root of x. So we got 4 divided by the cube root of x. Okay. Well, here's the thing. Remember, in order for a number to be considered, or an expression to be in standard form, you have to rationalize the denominator. Now, since it's a cube root, this is the cube root of x to the first. In order to rationalize it, you'll have to multiply both numerator and denominator by the cube root of x squared. So multiply both numerator and denominator by the cube root of x squared. Of course, in the denominator, you multiply that cube root of x times the cube root of x squared, you would get the cube root of x cubed, which would just give you x. So the best this is going to simplify into is 4 times the cube root of x squared all over x. That's the best we could do to simplify this. You'll get 4 times the cube root of x squared all over x. Alright, so we have the cube root of x to the third all over y squared. Alright, well, you have a fraction inside of a root under a radical, so we can split this up into the cube root of x to the third divided by the cube root of y to the second. Well, let's go ahead and simplify the numerator first. Cube root of x cubed is going to be what? That's just simply x. Now this would all be over the cube root of y to the second. Well, again, we have to rationalize the denominator. We can't have a radical in the denominator. So this is the cube root of y to the second. We're going to have to multiply the numerator and denominator by simply the cube root of y. Now, to simplify this, in the denominator, cube root of y squared times the cube root of y turns into the cube root of y to the third, which would just be y. So this is going to simplify into x times the cube root of y all over y. That's the best you're going to be able to do. X times the cube root of y all over y. I have about 2 more. big one here. So we have the square root of 9x squared y all over 32z to the third. Let's do ourselves a favor. Let's split this up into the fraction of two roots. So this would be the square root of 9x squared y all over the square root of 32z to the third. All right. Well, let's go ahead and simplify a bit. Square root of 9x squared, that's just going to give you 3x. Then you have that leftover square root of y, which there's really not a lot you can do with that. Now, here's where it gets fun. Square root of 32. In fact, let's split this up. We'll have the square root of 32 times, now z to the third. Couldn't we do the square root of z to the second times the square root of z? We sure could, because that would give you the square root of z to the third. I'm trying to make as many perfect squares as I can. Alright, so let's simplify the denominator a little more. So we still have 3x times the square root of y. Now, what is the square root of 32? Not a perfect square, but one of its factors is this will break down into 16 and 2. Square root of 16 is 4. So you have 4 times the square root of 2 times the square root of z squared, which would just be z, then times the square root of z. All right, so let's simplify even a little more. You have 3x times the square root of y all over 4z times the square root of 2z. Well, we still have to rationalize the denominator because you can't have a radical in the denominator. So that means you got to multiply both numerator and denominator by that square root of 2z. So let's do that. All right, so the numerator is going to simplify into 3x times the square root of 2yz all over, let's look at your denominator. 4z times square root of 2z times 2z, well, the square roots are gone, so you'd have 4z times 2z. That would be 8z squared. In fact, that's the best you can simplify. You'll end up with 3x times the square root of 2yz over 8z squared. Once you've rationalized your denominator, that's what you get. 3x times the square root of 2yz over 8z squared. And I believe there's only one more. Good one. All right, so we have the fifth root of x to the third divided by the seventh root of x to the fourth. So we have different roots in the numerator and denominator. How the heck are we going to deal with this? In that situation, when you have different roots, I'm going to suggest you convert this into rational exponent form. You'll see why in a minute. So, x to the 3/5, right? Oh, I'm sorry, fifth root of x to the third is the same as x to the 3/5 all over the seventh root of x to the fourth. That's the same as x to the 4/7. Now, we have to figure out which one's greater, 3/5 or 4/7. Because we need to know where to subtract. Actually, 3/5 is greater, so that makes life a lot easier. So now take 3/5 minus your 4/7. Alright, so this would end up with 21 minus 20 all over 35, which would give you 1/35. So this would literally turn into x to the 1/35, which would end up giving you the 35th root of x. So this simplifies into the 35th root of x. I bet that would be hideous decimal form if we put in any number for it. Alright, so that's it for this lesson. Next lesson, we're going to perform addition and subtraction with radical expressions for variables. So I hope everyone has a great day. Take care.